Now let's try to understand what kind of matrices there have to measure the clustering, how much good our clustering technique is, what kind of matrices we have. So already the series of supervised learning chapter we have seen there are various techniques for classifications and regression technique, means for the supervised learning techniques. So just recap this thing first. So for classification, the classifications and regression, if you remember, for classifications and regressions, so for our data sets we have got the output, we have the output for the supervised learning models, that's called OII. And for classifications, for this OII are mainly class level, and for regression problem, these OII are the regressor value. Regressor value. Okay, and these OII are called the truth value or actual value. In general, there have some books, many authors are write this OII as a ground truth value. Ground truth value, or it's the actual value. Okay, this OII are called. Now, the main job that we have for the classifications of regressions, so we have to predict the functions f for a given x, means we have to predict the how much accurate our y is to the actual or ground level accuracy. Okay, means we have to approximate the functions that gives the output as close as our ground truth value. That's the main job that we have to do in the classifications and regression problem, means in the supervised learning model. So to justify how much good our supervised models is, the technique that we have already seen, the techniques are the by simply using AUC matrix, by simply using R square matrix, by simply using the recall matrix, by simply using the performance matrix. Okay, this kind of matrix we have used. But the question is here, how to measure the clustering technique? Now the questions are how to measure it. How to measure a cluster, how much good the cluster is for a data sets, how much good this cluster. How to measure a clustering. So let's see. Let's try to understand this thing geometrically. Okay. So geometrically, what is the clustering regions? Geometrical, that's the questions that we have into our mind. If you geometrically, that's the questions that have into our mind. The what is a clustering? What is a clustering region? That's the questions. Now let's try to understand. So the data sets that we have to play the data sets. D, we have only single variable xi, and suppose let's take for easy of our understanding, for visualization, for easy of our visualization, suppose let's take the xi that we have that belongs to our two-dimensional data, means it belongs to R square. So suppose let's draw this thing. Suppose let's take the x R square, this is the for features 1, this is for features 1, this is for features 2, for this two-dimensional data, that's the data set we have. So let's take the data that we have given. If we scatter plot this data, it's look like this type. this type of data we have. Suppose let. So if you ask this thing for a 2-year kid, just group this data set. So they can easily grouping these things like that. Like that. It is grouped by. If you ask any persons that who have no any idea about mathematics, just group these two kind of data sets. They can easily separate this. This is a one group, this is another group. Now the question is in which basis we will find these is the two groups. So let's try to understand these things. So there are two type of things, means in intracluster and intercluster. There are two type of things. First one is intercluster, intracluster, intracluster. Intracluster. The second thing that we have, the intercluster. Intercluster. Okay, these two things we have. Now try to understand what is intercluster, what is intracluster. Intercluster means what? Intercluster means within a cluster. That's the main definitions of the intercluster. Means within a cluster, means I'm talking about all the points within this cluster. So it's better if I rename these things. Suppose let's take this cluster is for cluster 1, this cluster is for cluster 2. Just rename this thing. So intercluster means I'm talking about all the points that's between in this cluster, means in the cluster of class 1 and class 2. All the points are called the intracluster. Within a cluster. Now the second thing that we have, intercluster. Intercluster means across or between the cluster. Means I'm talking about between the cluster 1 and cluster. So just like this, view these points like that. So suppose let's take cluster 1 is a single point and cluster 2 itself is a single point. Now if you just visualize this thing to independently, cluster 1 and cluster 2, these things are called the intercluster. If you visualize these things into the cluster, then these things called the intracluster. And outside the cluster means the comparison between these two clusters are called the intercluster. So across, the definitions, it will be across or between the cluster, or it will be between cluster. Okay. Now how, using this concept intercluster and intercluster, how we will find these are the clusters? Let's try to get this answer. Let's try to get this answer one by one. If we use this intracluster, means I'm talking about the inside the point of the H cluster. So just see these things, the distance between the points, the distance between the H points into the H cluster, so it will be smaller. So the intracluster distance, so in general the intercluster distance is small. So the intercluster distance is small. In general, that's things happen. Intercluster distance is small. Now let's to find this answer. Intercluster distance. Inter means between the cluster 1 and cluster 2. I'm talking about C1 itself be one cluster and C2 itself another cluster. Now just see these things. The distance between these two clusters are large. The questions now, the intercluster distance is large. The answer now, the distance between the intercluster distance is large. Is large. Okay, that's the main primary core idea of the any clustering technique. This is the core idea. Now basis on this simple idea, we will try to some measurement metrics. Sure, this is the basic, this idea simple, the basic idea. These things are the simple, they call the this concept. These are the simple basic idea. of any clustering technique. Basic of how to measure a clustering. These are the simple basic concept. Okay. Now let's take. Now let's see the idea behind it. This is the simple idea. Now let's see the idea that we have got. The idea that we have got. So the intercluster distance should be very high. The intercluster distance should be very high, and the intercluster distance should be very low. The idea that we got from here. So the intercluster distance it should be very high, and the intracluster distance that we have it should be very slow, means very small, very low, as we call very low distance. Okay, now to measure how much clusters are better, there have one index, and there are many kind of. The most important means most general used technique are called the Dan index. It's the most general used, most generally. Typically math engineers, the data scientist, engineer, mathematician, scientist are use this index, Dan index, to measure the performance of any clustering technique. Dan index. It is the simple and it is the primary concept of the any indexing. Now let's try to understand how these things are. So Dan index is simple. The formula of the Dan index is denoted by D. D, in numerator of part, it will be max of. Just write the first formula, then try to understand geometrically. So just write the formula first. So in numerator portions, it will be the D of ij. So just patient with me. What is I, what is j, what is d? We will discuss everything step by step. Now in denominator portions, it will be maximum of k d dashed of k. Now try to understand. What is this? What is this ij? Suppose let's take, we have k, this k cluster. So here we have two clusters. Here we have two clusters. Suppose let's k for a data set, so we have got such kind of k cluster. Suppose let's take, we have k cluster. So such like that, C1, C2, C3, like that, k cluster we have, such kind of k cluster. Now the key, now ij that we have seen here, the maximum the distance dij means the I that is lying on that range, I, j, k, the index that's lying on the range 1, 2, 3 up to the class now, like on this thing. Okay, it's this distance. Now this distance means this distance means this is the simple distance between this dij. Just I'm talking about this just dij, this dij. This is the sample. This is the distance between the cluster Ci and Cj. These things are simple. It is the distance between the clusters Ci and Cj. This is the simple distance between the clusters Ci and Cj. Okay, now among all the distances between the each pair of clusters, we have to find the max one. Okay, we have to find the max one. That's the first thing. Now let's try to understand what is the d dashed. So the this dash is means the this dash distance means it is the intra-cluster distance. This is mean the intra-cluster distance. Intra-cluster distance means what? Means the distance between the within a cluster points. This is the intra-cluster. Intra-cluster means just take a single cluster and try to find the distances between each pair of points. And the maximum one that's we got, that's the this the denominator part that will. So the d dash case will be the intra-class distance for the cluster K. So it will be, just don't be confused. Suppose let's take it is the capital K. It's the capital K. So this is the capital K. Suppose it is the capital K. Now the thing is intra. Of K, of the cluster K, means of that cluster K that I am talking about. Intra-cluster distance of the cluster K. That means. Now, if you just see these things geometrically, suppose it will be better if you just take the picture geometrically. So just see these things. Suppose let's take the, suppose let's, for simple settle, let's take, we have two clusters only. This for features 1, this axis for features 2, and the data that we have, suppose let's take we have fewer points. Here we have some fewer points. Okay, if you separate these things, this data will be lie on a single cluster. This data will be lie on a single cluster. In a single cluster. Okay. Now, the basic idea that we have got, inter-cluster distance will be smaller. That means inter-cluster distance means what? Means distance between the edge pair of point between these clusters. Suppose let's take this the cluster 1. This is for the cluster 1. This is the cluster 2. Okay, means I'm talking about the intra-cluster, means the distance between the edge pair of points between the edge cluster. So suppose let's take this distance is the maximum distance of the cluster 1. And suppose let's take this distance, this distance is the maximum distance for the cluster 2. So first that thing that we have to do, we have to find pair of points. We have to find the, for every pair of points, within each cluster Ci. Suppose let's take cluster is denoted by Ci. Within each cluster, for every pair of points within each cluster Ci, I think it's better if I denote it, instead of using the Cl, if I use the Ci, it's better for us. Ci, it will also C2, C1, C2. So for every pair of point within each cluster, the maximum distance that we have to take as the denominator part, the maximum distance. Within the cluster, the maximum distance. That's thing that we have to use in the denominator part, in to denote this thing. This denominator, this will be the simple. Now let's try to understand the numerator part, means the maximum distance the maximum distance, one thing, in general, the basic idea, the basic core idea is that this distance will be, in general, this distance will be very small. This distance will be very small. This distance in general, it will be very small. Now let's try to the numerator part. What are these things? The numerator part now, here it will be the maximum distance between the intercluster distance, maximum between the intercluster. Now it is the intracluster. Now numerator part will be intercluster, intercluster. Now what is intercluster distance? So for finding the intercluster distance, that we have to find the distance between the cluster 1 and cluster 2. So there are various techniques to find the cluster distances between the edge clusters. So it will be centroid, for the centroid point for edge clusters, then define the distance. It's one technique. Another technique is just find the pair of distance for edge data points, and among that you have to find the largest one. This will be the farthest distance. So there are various techniques. The simple, just try to understand the intercluster distance. Try to understand this. So try to understand the intercluster. This is the simple, the intracluster distance. Now it is the inter. Don't be confused between these two twist term. Interdistance. Now how will find? So there are various techniques. Try to understand the simplest one. So the simplest one that we have. So find the pair of points between each pair of points. So for every pair of points, not only for each cluster, not only for the pair of points within a cluster, each cluster. Just first try to find the pair of points for between each data points. So for every DIs, means for every pair of DIs, it will be better. For every pair of DI and DJ, for every pair of DI and DJ, find, means I think for every distance is already denoted by DI, it will be confused for us. I think for the points, just write down simple points. For every pair of points, for every point of points, find the distances. D1, DIs means find the distances. Okay. Now in the second step, after finding this, that we have to find the maximum one. Find the maximum one among all the distances, among all the DIs. Okay. So we have to first find the edge distances, these from these to these, 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 like that. How much combination it is possible here? Here we have 4 points. Here we have how much? 5 points. 5 points. So 4 into 5 means 20 pair of combinations. So it is possible here. 20 pair of combinations. So here it is 4. This side will be 5. Then how much pair possible? 20 pairs it is possible. So to find this such kind of 20 points here. So among these 20 distances, we have to find the maximum one. That will be the intradistance. That will be actually our numerator part. Yeah, that is actually the numerator part here. That's actually the numerator part. And the distance, every pair of distance within the cluster. Means here we have 4 points. How much pair of possibles here? How much pair? 4 into 4. Means just it taken itself, it's necessary. So just take these things. It's 4, and neglect the diagonal elements. It's 4 elements. It's 12. I think it is possible. 4 into 4, 16. If you just remove the 12, this thing, 4 elements. 16 minus 12 means 12 type of possibles here. Okay, I think you got the answer. So now the question is how it interpreted, how much it is better, how much better. So simple, if you just write these things, how much good it is. If you just write these things, this means, I think it will for better way. I think if you write these things for a better way, these things will be this dij that we have used here, dij. It simple means the distance between the cluster for the edge point, the distance between ci's and cj's for the farthest distance. It will be distance between ci and j, and it is the farthest. At these points. Okay, these things that we got. The same concept. Being simple distance between, just I think you got the answer. This is a simple thing. Okay, now let's try to, these things means it is the maximum distance. If you mathematically notice this, if you just mathematically write down these things means it is the maximum distance between the h pair of distance, means the distance between these, means maximum one between the d1 dash, d2 dash. What is d1, d2? So this distance means this one, the here this one, it will be d1 dash. This farthest distance among within the classes, within the h clusters, means within the h clusters, and here the cluster 2, it will be the d2 dash, if these are the farthest distance. Okay, I think you got the idea. Among all these distance, we have to find the maximum. So that will be the denominator part. This one will be the numerator part. Now try to understand, so what the d is important, how much d is importance. So if we got the high value, means if we got this kind of pictures, if we got this kind of pictures, means for a good cluster points, so good set of cluster points, the picture of the good set of data point, but it's f1, suppose let's say it's f1, it's f2. So for a good cluster, means intercluster points will be much more closer. It will be like that, and the intercluster points will be like, and the intra-cluster, inter means intra-cluster, I'm talking the intra-cluster, and the inter-cluster points are more farthest, like that. So these things will be a intra-cluster, and these two things are called the intercluster. So this is a good clustering. If these things means, if we have a intra-cluster distance is small and intercluster distance is large, these things are called the good cluster, good sample of cluster. Good cluster means if these distances are small and the farthest distance between this farthest point, it's very large. If these things happen, this cluster we call the a good cluster. Now let's try to understand, let's try to visualize the d value on this thing, on these pictures. Okay, what is d? D means the maximum between the dij and didj, means the maximum distance of the intra-cluster points, means two different clusters, the maximum distance between the two different clusters. So we will see for a good cluster, this distance will be very large. So if numerator price will be very large, that means D will increase. So our in the D, just write these things. Just write these things. In D that we used, in D we have maximum value among what? Among the interclass among the interclass, and in denominator that we have maximum value among the intraclass. And for a good cluster, we will see interclass distance will be large. We will see for a good cluster, we will see the interclass distance, it will be large. If this value is large, means maximum of the large value will be also large. Okay, and we'll see for a good cluster, this value, for a good cluster, this interclass will be very small, and maximum of this also will be very small. That's the primary thing. In that means what? That means our numerator part will be large and denominator part that we have, it will be small. It will be small. If these things happen, that means what? That means what? That means the D value, that means the D is high. From these things we can conclude that if D value is our high, if we got the D value that is high, that implies our cluster is good cluster, that we have a good cluster. That's the primary concept, because if the interclass distance will be large, very large, and the intraclass distance will be very small, in the situations the cluster will be the good cluster, and on this basis we got the high D value. So large D value, large Dan index value, that means our cluster is so much good. That's the primary crack idea behind any cluster technique. Already in this series we will see the k-means all in this series we will see the k-means clustering technique, but as time progresses, as we learn various kind of clustering technique, then that kind of situations are the main primary basic concept. Using this basic concept we will extend our study. That's the first concept. Means the Dan index value is high, that means the cluster that we have, the data that we have, that's the good data for any clustering. That's the first basic primary concept for any clustering technique. So this is the core idea. Intercluster distance will be very high, intracluster distance will be very low. This is the main cracks of any clustering technique. I think you got the idea how the clusterings and measurements are useful. Okay, I think you got some idea from here. Now let's see, in next video we'll see how the k-means algorithms are work. Okay, now let's start the next lecture, the k-means algorithm.